Hello everyone, it's my pleasure to introduce myself, Akanksha Chouhan, currently pursuing Mtech IT 5 years from IIPS Davv. This video presentation is a part of my college assignment and is guided by Honorable Dr. Nitin Nagar Sir. The topic of the video presentation is TCP IP client socket, URL and URL connection. I would like to thank Dr. Nitin Nagar Sir for explaining me the concepts, clearing my doubts, and being an amazing mentor. So without further delay, let's get started. Since one of the topics which we are going to cover today is TCP IP client socket, so the first question which comes to our mind is that why do we need socket programming? Suppose we have two machines, a client machine and a server machine. In order to connect the client machine with the server machine, we require a socket. Now suppose we have two clients, client 1 and client 2. Client 1 has a socket and client 2 has a socket. So in order to connect both of the client machines with the server machine, we require two sockets at the server side. The server socket class is responsible for creating these sockets inside the server. Now two things are required by the client in order to connect to the server. First, the IP address of the server, and second, the port number. The IP address of the server is required because there are billions of servers in this world, and in order to connect to a particular server, we need its unique IP address, and each IP address is unique to a particular server. Every server has a unique IP address. Now, there will be many applications running on the server, and each application has a unique port number. So, in order to connect to a particular application, we require the port number of that particular application. Also, if the client wants to connect to the server, it sends a request to the server and the server responds back to the client after accepting the request from the client. Once the connection is established between the client and the server, the communication can take place between the two machines. The topics which we are going to cover today in this video presentation are Introduction and use of socket programming. Then we'll see the types of socket programming, classes used for the two types of socket programming, what is a socket, the methods of socket class, what is a server socket class, the methods of server socket class. Then we'll be seeing how communication takes place between the client and server by implementing it through a program, what is a URL, the components of URL. Then we'll see how can we create a URL. We'll also study about relative URL, the constructors of URL class, how to parse a URL. Then we'll be implementing the methods of URL class, and then we'll see a brief introduction about the URL connection class. So let's get started. Now we'll see what is socket programming. The use of socket programming. Java socket programming is used for communication between the applications running on different JRE. The next question which strikes our mind is that what are the types of socket programming? So the types of socket programming are connection-less socket programming and connection-oriented socket programming. A question comes to our mind is that if there are two types of socket programming, what is the difference between two types of socket programming? So, in connection-oriented socket programming, the acknowledgement is sent by the receiver to the sender, whereas in connection-less socket programming, no acknowledgement is sent by the receiver back to the sender. The socket and server socket classes are used for connection-oriented socket programming, and datagram socket and datagram packet classes are used for connection-less socket programming. Now, we have seen what is a socket programming, so let us see the methods of socket class and what is a socket class. So, a question comes to our mind is that what is a socket? A socket is simply an endpoint for communication between the two machines. The socket class can be used to create a socket. Now let us see what are the methods of the socket class. There are three methods of the socket class. Public input stream get input stream method, public output stream get output stream method, and public synchronized void close method. Public input stream get input stream method returns the input stream attached with the socket. Public output stream get output stream method returns the output stream attached with the socket. And public synchronized void close method is used to close the socket. Now, let us see what is server socket class and what are the methods of server socket class. The server socket class can be used to create a server socket. The methods of server socket class are first, public socket accept method and public synchronized void close method. Public socket accept method returns the socket and establishes a connection between the server and the client. The public synchronized void close method closes the server socket. Now, since we have seen the introduction to socket programming, what is socket class and its methods, and server socket class and its methods, now let us dive into the practical implementation. We will be doing a program and I will implement it on my system and explain it to you. Now, let us move to the practical implementation part where we will be seeing the program. The client connects to the server and sends a message to the server. The server displays the message. Here we will make two classes or two programs, that is myclient.java and myserver.java. I will be implementing this program on my particular system and will be using localhost. The first program is myclient.java. First of all, we import two packages, java.io package and java.net package. The java.io package provides API to reading and writing data. The java.net package provides the classes for implementing all the networking applications. We make a class myClient, and in order to open a socket, we make an object of the socket class and provide the IP address and the port number of that particular server. We provide the IP address in order to identify a server and in order to connect to a particular application running on a particular port in the server, we need to provide its port number. Then we make the object of data output stream class. Data output stream class allows application to write primitive Java data type to the output stream. The get output stream method returns the output stream attached to the particular socket. Now, we write the primitive data of this string in modified UTF-8 format through the write UTF method. Here, the client sends the message hello server to the server. Then we close the output stream object and finally close the socket. Now let us move to the program myserver.java. The server application makes a server socket on a specific port, which is port 5000. This starts a server listening for the client request coming in for port 5000. Then the server makes a new socket in order to communicate with the client. The accept method blocks until a client connects to the server. Then we take input from the socket using getInputStream method. After we are done, we close the connection by closing the socket as well as the input stream. Similar to the myClient class, here we import two packages, java.io package and java.net package for the similar purpose. Then we create the server socket object to the same port. The accept method is used to establish a connection. Now, we read the message through the getInputStream method attached with a particular socket and finally display the message on the server side. Then we close the server socket. In case any exception occurs, we have provided the code inside a try block. The catch block catches the exception and displays the particular error. Now we will open two command prompts on our system and migrate to the folder where both the programs are stored. We will be opening two command prompts. First we will open the command prompt, migrate to the folder, and then we will compile our file myserver javac myserver.java. Our program is successfully compiled. Now, in order to run the program, we need to, first of all, we will run the server. Java myserver command is used to run the program. Our server program is successfully run. The server is waiting for the client to send the request. Now we will compile our myclient.java program. The program is successfully compiled. Now we will run the myclient program. The client will send the request to the server will accept the request, and as mentioned in the program, will print hello server message. When we run the client program, the message, you can see the message hello server is displayed on the server side. So this completes our implementation part. The next topic which we are going to cover today is URL. The first question which comes to our mind after listening to the word URL is that what is a URL? URL is an acronym for Uniform Resource Locator and is a reference and address to a resource on the internet. A URL basically has two components, protocol identifier and resource name. For the URL http://example.com, the protocol identifier is HTTP. The next component, that is the resource name. For the URL http://example.com, the resource name is example.com. Now let us explore protocol identifier and resource name, the two components of the URL. The protocol identifier indicates the name of the protocol to be used to fetch the resource. The example which we had mentioned before uses the Hypertext Transfer Protocol HTTP, which is typically used to serve hypertext documents. The resource name is the complete address to the resource. The format of the resource name depends entirely on the protocol used. But for many protocols including HTTP, the resource name contains one or more of the following components. The components of the resource name are host name, file name, port number, reference. Host name, the name of the machine on which the resource lives. File name, the path name to the file on the machine. Port number, the port number to which to connect, typically optional. Specifying the port number is an optional part. Reference, a reference to a named anchor within a resource that usually identifies a specific location within a file. Mentioning the reference is also optional. For many protocols, the host name and the file name are required, while the port number and the reference are optional. Now, we will see how to create a URL. Creating a URL. The easiest way to create a URL object is from a string that represents the human readable form of the URL address. We create an object of the URL class, and in the constructor, we specify the URL address. The URL object created above represents an absolute URL. Now, what is an absolute URL? An absolute URL contains all of the information necessary to reach the resource. We can also create a relative URL address. Now, what is a relative URL? A relative URL contains only enough information to reach the resource relative to another URL. Relative URL specifications are often used within HTML files. In our Java programs, you can create a URL object from a relative URL specification. Now let us consider an example where two URLs at the site example.com. These are the two URLs. You can create URL objects for these pages relative to their common base URL http://example.com/pages like this. First, we create a URL object, my URL, and specify the address of the URL. Then we create page 1 URL by creating the URL object and mentioning the first URL and then the page number corresponding to it. Then we specify the second URL, and in the constructor we pass the URL object of the specific page, and then we specify the next parameter, which is page2.html. Then now let us see about some constructors of the URL class. The first constructor, URL string spec, which creates an instance of a URL from the string representation. The next constructor takes in three parameters: protocol of string type, host of string type, port of integer type, and file of string type. It creates an instance of a URL from the given protocol, host, port number, and file. The next constructor takes in a total of 5 parameters: protocol of string type, host of string type, port of integer type, file of string type, and handler of URL stream handler type. It creates an instance of a URL from the given protocol, host, port number, file, and handler. The next constructor takes in 3 parameters: protocol of string type, host of string type, and file of string type. It creates an instance of a URL from the given protocol name, host name, and file name. The next constructor takes in 2 parameters: context of URL type and spec of string type. It creates an instance of a URL by parsing the given spec within a specified context. The next constructor takes in 3 parameters: context of URL type, spec of string type, and handler of URL stream handler type. It creates an instance of a URL by parsing the given spec with the specified handler within a given context. Now, we will see the malformed URL exception. Each of the 4 URL constructors throws a malformed URL exception if the arguments to the constructor refer to a null or unknown protocol. Typically, you want to catch and handle this exception by embedding your URL constructor statements in a try-catch pair like this. So, in short, if we mention any URL address that is unauthenticated or it is wrong, it throws malformed URL exception error. So, we place this code inside the try block and catch the malformed URL exception inside the catch block. Now, we will see how to parse a URL and the methods for parsing a URL. The URL class provides several methods that let you query URL objects. You can get the protocol, authority, host name, port number, path, query, file name, and reference from a URL using these accessor methods. First method is getProtocol method. It returns the protocol identifier component of the URL. Next method is getAuthority method. It returns the authority component of the URL. Next is getHost method. Returns the host name component of the URL. GetPort method returns the port number component of the URL. The getPort method returns an integer, that is the port number. If the port is not set, it returns -1. GetPath method returns the path component of the URL. GetQuery method returns the query component of the URL. GetFile method returns the file name component of the URL. The getFile method returns the same as getPath plus the concatenation of the value of getQuery if any. GetRef method returns the reference component of the URL. Now, I have made a similar program for this. The problem statement is that given any string specification of a URL, just create a new URL object and call any of the accessor methods for the information you need. This small example program creates a URL from a string specification and then uses the URL object's accessor methods to pass the URL. First we import the java.net package and java.io package. Then we create a class called passURL and we create an object of the URL class and mention the URL address. Then we call the method getProtocol, getAuthority, getHost, getPort, getPath, getQuery, getFile and getRef method on this URL object. You can see this. I have compiled the same program on my machine and the output is this. Now we move to the next part, that is the URL connection class. The URL connection class contains many methods that let you communicate with the URL over the network. After we have successfully created a URL object, we can call the URL object's open connection method to get a URL connection object or one of its protocol specific subclasses. The URL connection object is used to set up parameters and general request properties that you may need before connecting. Connection to the remote object represented by the URL is only initiated when the URL connection.connect method is called. When you do this, we are initializing a communication link between our Java program and the URL over the network. For example, if we see the following code inside the try block, which is a connection to the simple site example.com, we create an object of the URL class and mention the URL address. Then we create an object of URL connection class, and with the help of open connection method, we get a URL connection. Then we call connect method on this object in order to connect to a remote object represented by the URL. Also, we catch the malformed URL exception and the IO exception in case any exception occurs. A new URL connection object is created every time by calling the open connection method of the protocol handler for this URL. Now we have successfully connected to our URL and we can use the URL connection object to perform actions such as reading from or writing to the connection. This ends our discussion today.